So in this case, we're actually printing right here at the show this component, which is what it's going to end up printing when it's all said and done, which is a replacement part for the printer itself. It's actually this housing right back here that's we call it the tower cap. So I'm actually printing a replacement part for our printer right here at the show.
Hi, I'm Steve Plumb, Editor-in-Chief of SME Media. We're here today at CES 2026 with Rob Ortiz, Director of Formlabs. Thanks for joining us today.
That's my pleasure.
So now your first rodeo as it comes to CES.
No, not yet.
But today you're part of the Advanced Manufacturing Showcase, which is really working with CTA, SME, and all the co-exhibitors like Formlabs about how products are made.
Yep.
How important is it to tell that story?
So one of the things I'm really passionate about the fact that we've been doing this is, in all my years at CES, it's always been about the consumer and the focus on the end product. Mm-hmm. But how that product is made is just as important, if not more so. We have a lot of really cool innovations, but we haven't talked about the innovations in making the things that are so innovative. And if we don't stay ahead in how we're making stuff, it's going to be really hard to have continual CESs that show off really cool new technology in the future. So I'm really passionate that this has been a new advantage that's been brought to the show.
And we have the knowledge bar, which you spoke at earlier.
Yep.
And talking about reshoring and bringing back those innovations and manufacturing jobs to the U.S.
Yep.
How does 3D printing play into that?
So let me give you an example. So this is a product from a company called Cool Parts. Mm-hmm. And so they're a company that was getting these parts manufactured. They do blown insulation equipment, and they do a fairly small yield of it. They were getting these parts manufactured overseas, and they ran into a lot of lead time issues, and at one point they lost the ability to produce those parts, and they were trying to do them in aluminum, machining them, and it just wasn't something they could either hit the lead times, the cost, at the small yields they were trying to do. So they came to Formlabs, and we were able to reproduce this part in our tough material, which is equivalent to an HDPE type of material, and it's performed as well as an aluminum part being printed in-house.
Is it really as strong as you say? Can it really stand up to traditional manufacturing?
Well, interesting you say stand up to, because I'm not as tall as I look here. I'm actually standing on this part right now.
Let me see.
Right there. So we have spent a ton of time proving that not only are these parts capable of manufacturing at low yield injection molded qualities and quantities, but they're able to perform just as well in outdoor environments, in wet environments, in sunlit environments, equal to an injection molded component. In fact, we've got a couple other examples too. So we're manufacturing parts that are equivalent to high definition polyurethanes, high density polyurethanes, polypropylenes, ABS plastics. So I can have parts that are able to survive being hit by a pickleball racket. I have components that are compliant and can have tons and hundreds of cycles to them. We've even gone so far as to have people that are producing end-use parts that you can now purchase. So this is a Zero Mouse. It's actually a part that's fully 3D printed. It's an available product for people to purchase, all being printed right in-house.
So you're talking about going from prototyping to commercialization and high-volume manufacturing. What's really been the enabler to push it over the edge?
There's really four things that we had to look at. One is mechanical properties. So if you want to be able to make something in-house, it has to be equal in strength and capability to if you're getting it from another source, an injection molding or a machining operation. So it has to be equal in material. Second, it's got to look similar to. It's got to be a high enough resolution, a high enough tolerance, a high enough detail that it's an interchangeable component. Third, it has to be fast. So it's got to be produced quickly. Now, we have the advantage if you're reshoring it that you can make it here in the US. You don't have to wait 6-7 weeks for something to come overseas, but we also still need to make whatever the production volumes are. And the last, but certainly not the least, is cost. We've got to make it so that it's cost effective to do that. And one of the things at Formlabs is we've been working on trying to produce parts that have a high rate where it costs the same to do it injection molded as it does 3D printed. So this is an example here. I actually have some parts that are injection molded and some that are 3D printed, and we show them to customers all the time, and they can't tell us which are which. This part has about a 13,000 part break-even cost. So if you're making less than 13,000 parts, it's more cost-effective to do it 3D printed.
Okay. So one of the advantages of additive manufacturing also is reduced waste, material waste. But also here, you're 3D printing in a closed loop where you actually have a replacement part.
Yeah, so in this case, we're actually printing right here at the show this component, which is what it's going to end up printing when it's all said and done, which is a replacement part for the printer itself. It's actually this housing right back here. That's we call it a tower cap. So I'm actually printing a replacement for our printer right here at the show.
Amazing.
It's amazing what's happened in the last couple of years, and if there's anything that we can extend out to your audience and viewers, it's 3D printing has changed drastically in just the last 3 years.
Well, that was my next question, actually. 3D printing has been around in current form in about 35 years or so.
Yep.
Last 3 years, you saw an acceleration. Where do you see it going from here?
It's all about chemistry right now. So the technology has improved, but really the biggest breakthroughs are coming in the polymers, in the ability to do it at speed, and to reduce the costs. And if we can do that, then it's much more easy for people to manufacture the parts here in-house.
All right, thanks a lot.
It's been a pleasure. Thank you so much.